Hi, I'm Phil Robbins, and this is another look behind the architecture of IntelliconOps. In previous videos, I've shown IntelliconOps provisioning infrastructure across the public clouds of AWS, Microsoft Azure and Google Cloud. In this video, I want to go a little deeper into how IntelliconOps actually reaches and manages those cloud workloads. The important part is that IntelliconOps control plane isn't actually running in any of those clouds. It's running here on my Windows development workstation using WSL, Docker and a set of encrypted WireGuard tunnels. For a single user development environment, that keeps the control plane local and lightweight. But the same platform could also be deployed on a Linux host or a container-based cloud platform such as DigitalOcean, allowing multiple users to access a shared IntelliconOps control plane rather than running it on an individual workstation. So let's look at what actually makes up that control plane. Windows 11 provides development workstation and browser interface. Inside Windows, Ubuntu runs under WSL 2 and provides the Linux networking environment that IntelliconOps uses. Within WSL, Docker hosts the IntelliconOps application and its supporting services. The PHP application provides the user interface while the Python worker handles the orchestration and executes the infrastructure automation. That separation is important because the web application doesn't need to directly manage the cloud networking itself. The worker can establish the secure management path and execute operations against the target environments. And that brings us to the next part of the architecture. How a locally running worker reaches private virtual machines inside AWS, Azure and Google Cloud. That's where WireGuard comes in. The Python worker maintains separate WireGuard interfaces for each cloud environment. AWS uses WG15 and Google Cloud uses WG16. Each tunnel has its own dedicated address range. That separation is deliberate because it prevents routing conflicts when several cloud connections are active at the same time. At the cloud end of each tunnel is a small Ubuntu router. So Azure has a router VM, AWS a small EC2 instance, and GCP has another small router VM. Those machines act as the secure entry points into their respective private cloud networks. So why did I use router VMs? There are a few design decisions behind this. Firstly, I chose WireGuard because it's lightweight, fast and relatively simple compared with deploying a much larger VPN stack. Secondly, each cloud gets its own small router VM. That gives IntelliconOps a predictable routing point into each environment without requiring every workload VM to have a public IP address. It also keeps the cloud-side infrastructure relatively inexpensive. And because the actual IntelliconOps worker remains inside Docker in my workstation, I don't need to maintain a separate cloud-hosted IntelliconOps control plane just to manage these environments. The public-facing component is effectively the WireGuard gateway. The workload machines behind it can remain private. Each cloud router is deliberately very simple. It's a minimum Ubuntu machine running WireGuard with IP forwarding enabled. Traffic arrives through the encrypted WireGuard tunnel and is then forwarded into the cloud workload network. There are some cloud-specific differences underneath. Azure requires IP forwarding on the router's network interface. AWS requires the normal source and destination checking behavior to be disabled on the router interface, and GCP has its own forwarding configuration. IntelliconOps can hide those cloud-specific differences behind a common operational model. From the platform's point of view, they're all simply secure routes into private infrastructure. There's another useful part of the design. The Docker worker isn't the only component with access to the Azure tunnel. WSL itself has a WireGuard peer. That means I can route traffic originating from Windows through WSL and across the encrypted tunnel. My local Windows network is completely different from the Azure network. My workstation is on a normal 192.168.0 home network. The Azure workload I'm going to demonstrate is at 10.0.0.7. Windows wouldn't normally have any idea of how to reach the private address, So I add a route telling Windows that traffic destined for the Azure 10.0.0.0/24 network should be sent to the WSL interface. In this case, 172.19.34.73 is the WSL address, so the route effectively becomes Windows to WSL through WireGuard to the Azure router, and finally into the private Azure workload network. So let's move away from the diagrams and look at the actual platform. Here I can see the cloud environments IntelliconOps is managing. I've currently connected Azure, AWS and Google Cloud. Behind those connections are the WireGuard gateways we've just looked at. The important point is that these aren't simply entries in a dashboard. IntelliconOps can actually see these tunnels to execute operations against the private machines behind them. And that's what I'll demonstrate next. This is a private Ubuntu VM running on Azure at 10.0.0.7. Rather than exposing SSH on this VM to the public internet, IntelliconOps reaches it through the WireGuard gateway. I'm now going to use the Day 2 operations capability to make an actual configuration change. I'll ask IntelliconOps to install Apache and configure the default web page to display a simple Hello World message. IntelliconOps takes that requirement and turns it into an infrastructure operation. The platform handles the workflow and orchestration, and the resulting automation is executed against the VM across the private management connection. I can review what is being executed, run the operation and see the result coming back into IntelliconOps. So this isn't AI simply explaining how Apache could be installed, it's AI participating in a controlled operation against a real machine. And now we can prove the whole path from outside IntelliconOps. I'll open a browser directly on Windows and go to 10.0.0.7. And there's the Hello World page we just deployed. What's interesting is the path that request has taken. My Windows machine isn't part of the Azure network. The Azure VM doesn't need a public web or management address for me to reach it across the private route. The browser traffic goes from Windows into WSL, across the WireGuard tunnel, through the Azure router and finally to the private VM. And that's really why I've built the networking this way. IntelliconOps needs to be able to perform real infrastructure operations, not simply call public cloud management APIs. Day 2 operations eventually mean interacting directly with the operating systems, services and applications. WireGuard gives the platform a secure management path into those private environments while keeping the workloads themselves away from the unnecessary public exposure. And because IntelliconOps abstracts the individual cloud implementations, the same operational model can be applied across Azure, AWS and Google Cloud. So that's the networking architecture behind IntelliconOps today. A Windows development workstation, WSL and Docker providing the local control plane, Python handling orchestration, WireGuard providing encrypted connectivity into the clouds, small cloud routers providing access to the private workload networks, and IntelliconOps bringing all of that together so that a simple request can become an actual Day 2 infrastructure operation. There's still plenty more to build and I'll continue documenting it as IntelliconOps develops. If you're interested in cloud architecture, networking, infrastructure automation or AI-driven operations, follow the series here or take a look at IntelliconOps.com.